Hi, I am Dinush Kumar. I am going to talk about my MSc project Automated Diagnosis of Disease Pneumonia and Pulmonary Tuberculosis. Uh, First of all, I am going to talk about introduction of my project, next problem domain, like that. Finally, I am going to talk about conclusion. In my project introduction, tuberculosis is a bacterial lungs disease caused by bacterium Mycobacterium tuberculosis. Tuberculosis symptoms of tuberculosis like weight loss, loss of appetite, a long-term cough than 3 weeks, cough in up bloods, weakness of fatty, fever, and night sweats. Pneumonia is a inflammatory condition of the lungs. Early diagnosis and treatment is very important to reduce the disease. However, pneumonia is also caused to death. A chest X-ray is often used to diagnose pneumonia. White blood cell count is complete blood count can be identify infection level, and blood test also can confirm the germs. Also, pulse oximeter are used measured oxygen level in the blood. In patient having tuberculosis, the chest X-ray will be changed than normal chest X-ray. Fibro tissues may be built up in infected lungs because of the bacteria and their toxin. Then lungs tissues getting fibrosis and hard. Chest X-ray will appear like a whole bundle and patches like image in affected area. Tuberculosis could be a major case of sick health, one of the best cases of passing around the world, and driving cause of passing from the single irresistible agent. International in 2019 evaluated 10 million people fell sick with tuberculosis. There were 1.2 million tuberculosis passing among HIV negative persons, and extra 208,000 deaths among HIV positive peoples. Next problem domain. If some patient having cough or fever, high fever, family doctor may not be diagnosed as tuberculosis or pneumonia in the first time. They give medication, treat cough, and reduce decline other symptoms. If these medication are not treatable for the patient, revisit the patient in the same doctor or another doctor. In here also giving the medication and send them back to the home or starting to do investigation. In this situation, initial investigation is chest X-ray. By reading chest X-ray, physician can identify the disease tuberculosis. In some cases, difficult to identify the difference between pneumonia and tuberculosis separate by using chest X-ray. In here, user can use automated diagnosis of tuberculosis and pneumonia, both using chest X-ray and using automated diagnosis method is advantage to the patient. Some X-ray machines are old and their images are not clear in some rural hospital and rural areas. In private sector also. In tuberculosis and pneumonia, there are some hole-like structure in X-ray, but some cases doctors can't identify in some images about their unclear condition. Using automated diagnosis method may help to doctor to decide the condition. There are several methods to diagnose tuberculosis. There are skin tests. This is also known as Mantoux tuber cleaning skin test. Doctor injects some medicine to the skin, and after 2 or 3 days check for swelling of injected area. If there is some swelling of redness, they diagnose as a tuberculosis patient. There is a blood test to identify the tuberculosis, and other simple test is chest X-ray. Chest X-ray initial and comfortable way to the identify tuberculosis and pneumonia. If some patient having only cough, most doctors don't suspect that this is tuberculosis. In this situation, patient may be going to bad condition. There are many similarities between both disease, tuberculosis and pneumonia. So a main part of this research project focus on image processing and tuberculosis and pneumonia. The lack of this research project is specific on pulmonary tuberculosis and pneumonia further strengthens the essential for the new research. This suggested system target to address this problem by using intelligent image processing based solution. Next, this is the research gap. For active scholarly radiologist explain a test set on with the relate the perform of chest X-net to of radiologists. There are 70 strengths and but try to detect so many diseases using without good data sets. The histogram equalization, middle channel and construct limit multipurpose histogram equalization were connected to the extent picture excellence. The segmentation was some complete by using ACM, that means active control model. The outcomes of this technique produce 66%, sensitivity 86 and accuracy is 76, but the X-ray pictures used as input to the application taken from some hospital database which comprised of 300 typical X-ray images. That 300 images, that X-ray pictures. This is the research gap of this project. In proposed solution, doctors, nurses and radiologists can use this application. Chest physician and doctors can do the self-judgment less time accurately, and so the proposed solution for this problem is to detect the disease by using this automated diagnosis of the disease pneumonia and pulmonary tuberculosis application. It is a very useful and easy to medical staff to use this application. The project aim, this automated diagnosis of disease pneumonia and tuberculosis application is to develop an algorithm to have identification of the disease of chest X-ray and also the different between other diseases. Especially this application provide the probability of other disease also. The implementation of this project aim is using this application. Chest specialist and doctors can do self judgment less time accurately. This is the project aim. Next, system design. This is my high level architecture. There are two layers, presentation layer and second one is data layer. User directly work with presentation layer. The user can upload the image for the presentation layer, then data layer processing that uploaded image with pre-trained model. There are pre-trained data sets. Through that data set should do the detection disease and finally display the detection result with probability. Now we can move to the my project. This is my project. In here I import what I want libraries for my project, NumPy, TensorFlow, like that. Next I check the GPU available or not. In here import my data set, test data and train data. There are three types of data: normal data set, pneumonia data set and tuberculosis data set. Number of number of data set will appear here. I have 1000 normal images, 1000 pneumonia images and 1000 tuberculosis images. all together 3000 images here. Next, declare the figure will be 10 by 10. This function is from the matplotlib library. I use the fig size here. Declare the size. Declare for loop, print images 0 to 9. There will be 3 images vertically and 3 images horizontally. This is for normal images. In here I did same thing for the pneumonia images, and here did for tuberculosis images. In here I found 3000 images belong to 3 classes: train data set and test data set. I belong to 3 classes for the test data, 1500 images for the test data. Next, in here I will get the sample training label. Train batch and test batch, I am using standard values here. In here, getting the index of the parameters, number is 0, so normal is 0, pneumonia is 1, and tuberculosis is 2. And next, I here declare list the 3 labels for the images: tuberculosis, normal, and pneumonia. Declare the 2 variables in here: sample data and sample label. These 2 variables are used to store the images and the label of the images from the test data. Next, plot a figure of size 10 by 8 using the fig size argument with matplotlib. Loop that starts 0 to 12. This loop retrieve the image and place the images in the correct spot in the matrix. So next, use the IamShow method to display the data, and finally use plot title show the label for each images, which is either normal, low, pneumonia, or tuberculosis. Here I import efficiency net. Next, in here display the training curves, set up subplots on the first core. In here face color is gray. I am using in here hexadecimal values. And next, in here using keras, this is first create a model that map in input image to activation of the last convolutional layer. Compute the gradient of the top predicted class for input images with respect to the activation of the last convolutional layer. The channel wise means of the resulting feature map is heat map of classes activation. And here rescale the heat map range 0 to 255. Create the image with RGB color size heat map. And label smoothing is the mechanisms for encouraging the model to less confident. Instead of minimizing cross entropy with hard targets, minimizing it using soft targets. In here using monitor quality to be monitored, min delta is minimum change in monitored quality to qualify as an improvement. In here class weight here. Next, I use the density efficiency net and VG16. In here the 2443. Next, used to instant a new density architecture. The parameters of input shape have been passed is as well as the weight have used ImageNet as weights for loop that iterate through the layer in the pre-trained density and set of trainable parameters for loop parameters to false. Define variable x1 and assign to pre-trained density output to it. Set the average pooling operation for partial data, and in here flatten the input. Declare the type of densely connected neural network layer and use in ReLU. Apply in the dropout. Here applying the dropout to the input, which in this case it is 0.5. Finally has a variable defined model out, which is used to store the output model. Next, in here I put 30 epochs and train the data. In here using the display training curves functions, display two graphs to represent the model loss and model accuracy. With each epoch you can see that the accuracy increase and loss decrease. I used for this 30 epochs. The training lines shown the accuracy and the loss during training, whereas the validation line shows the accuracy and loss during validation. In here I use declare the two variables. First variable hold a name of the last convolution layer. Second one, this variable is used to store a list of classifier layer. After that here used to retrieve the image, test image. The first image declare the variable to store the location of the test image. Next used to read the test image from a given path. This is done by using OpenCV Python library. And next used to resize test image 224, and we entered pneumonia image, and here also we predicted it as a pneumonia. In here display the heat map. Next, new image called S image. This is used to impose the test image within the heat map I created earlier and display the image. In here used to declare a new figure of 10 by 8 inch. For loop I declare a new subplot. There are 4 columns and 3 rows. Remove the axis from all the graphs and create a new heat map which will be superimposed on each image to create a new image, new display. Next I displayed the image using IamShow function here, and declare the title for each image. I display the type of images, normal, pneumonia and tuberculosis, and the as a prediction. After that that train model I save here, and again in here I am using EfficiencyNet architecture. There are also for loop that iterate through the layer in the pre-trained EFNet and sets the trainable parameters as false. So here also using ReLU, applying the dropout to the input, which in this it is 0.5. and next I put 30 epoch here and I train the data. and here also I display model loss and model accuracy, and after that here declare the two variables, and again using sample data and sample label here do the prediction. You can see pneumonia is pneumonia, tuberculosis is tuberculosis, like that. Again that efficiency net, that train model saving as a H5 file. Next used to install a new VGG16 architecture here, and here also using ReLU dropout and 0.5. This is the part total parameters here, and here also again put the 30 epoch can train. After that display the model accuracy and model loss and model accuracy. Again display the type of images, declare the variable, and again display the type of images, normal, pneumonia and tuberculosis, and the prediction. Again that VGG model also save as a H5 file. In here the first for loops used to set of trainable option in the layer of the three neural networks that I trained previously to false. Next make instant a new Keras TensorFlow which will allow to build Keras model. Next declare the three variables x1, x2, x3 which will be used to extract the visible parts of the three previous model which I trained. Next I will merge these models by using TensorFlow Keras layers, a library from TensorFlow. Finally create the new densely connected neural network layer. There is the activation parameters, which is the element which activation function, and there is the name, which is name for the model. Finally compile the model, and I display the summary of the model here. This is the summary of the model. In here install PyDot, that image. Again I put 30 epoch and do the training, and display the model loss and model accuracy here. Then after that I save that train model as a H5 file. Now I can move to the now we finish the training part, we can test it. Run it. First we can run normal images. This is the path. This one is we train H5 file, and here label which we use this label I put here, and we entered normal images. The prediction, this is probability of the result. Normal is 47, pneumonia is 35, and tuberculosis 17. Then it goes to normal category. We can check again normal one. Run. It is running. It will take some time. We entered normal. 0.78 is normal. Pneumonia is 0.12, tuberculosis is 0.09. So it is goes to highest one is normal. It goes to normal category. Now we can check tuberculosis one. run. It is running. We entered tuberculosis image. Normal is 0.06, pneumonia is 0.17, tuberculosis 0.77. Then it goes to tuberculosis. That is also correct. Next we can put again tuberculosis. Run this. It is running. Yeah, it is tuberculosis normal 0.8 1873. It goes to tuberculosis. Now we can move to the pneumonia. We can run this. It is running. My data set is here. I am using this data inside test folder. You can see the path. Yeah. We entered pneumonia. Normal is 17, pneumonia 66 in 16. Then highest one is pneumonia. Prediction is pneumonia. Again we can put another pneumonia image. Yeah, it is running. It is also pneumonia. Normal 17, pneumonia 70, and tuberculosis 11. Then it goes to as a pneumonia. Now we can go to the checking mild pneumonia. On that running, we entered mild pneumonia image. The path is mild pneumonia. You can see here. This is, I entered to this image. You can see the result. Yeah, this is misdiagnosis of the system. We entered a mild pneumonia image. Now 47 normal, 39 and 17. Then it goes to normal. This is wrong misdiagnosis of the system. Again I put mild pneumonia image. It is running. This one also as a predicted as a normal image, normal check X-ray. Yeah, this is my demonstration. We can move to the PowerPoint presentation. System design. GuardCam architecture. The GuardCam could be a prevalent technique for visualizing via CNN, that means convolutional neural network. So it look GuardianCam is class specific since it can create and isolate visualization for each cause show within the picture. GuardCam can be used for weakly supervised localization. Example, deciding the area of a specific object, employing a demonstrate that was trained only whole image name instead of express area annotation. And similarly to GuardChem heat map is a weight combination of feature maps, but followed by a ReLU. ReLU is a perfect choice in this case, as it highlight feature having positive influence on the class of interest, regions of interest, implicitly refer to those pixel whose intensity varies directly with the gradient is yc. Without using ReLU, it is observed that localization map sometimes might include more information than the favorite class, like negative pixel that probably belong to other categories in the image, hence affecting localization performance. The implementation, the proposed machine learning framework is Python language. Therefore, selecting a language such as Python independent throughout the support of web-based application development, and there are used by some libraries. There are called TensorFlow and Keras. Image processing part can be completed by using these libraries, and Collabs used for the global development, and Jupyter used for the local development. This is my data set. This is my data sets. Inside data folder, two folders, train and test, each of that normal, pneumonia and tuberculosis folder. I use normal 1000 images, and pneumonia 1000 images, and another 1000 images for the tuberculosis training process. And I used 500 images, normal 500, and pneumonia 500, and tuberculosis 500 images for the testing purpose. This is the data set. I used density net, efficiency net, and VGG. I explained this in the demonstration. This is my heat map, and model loss and model accuracy. Accuracy is going high and loss is going down. You can see here. This is the training part. I took more than 24 hours for the train the data. In testing part, I did functional testing and non-functional testing. This is my functional testing, and the accuracy testing, I performed 10 cases in each category: normal and pneumonia and tuberculosis. There I recognize something special, that is the image with the mild pneumonia. I show you in the demonstration. The image within mild pneumonia condition are identify as healthy. That means normal chest X-ray image. It can be seen in the pneumonia table here, that orange color. It can be pointed out the misdiagnosis of this system. And here tuberculosis. In this equation, I got the accuracy from tested 10 images from the normally chest X-ray, pneumonia chest X-ray, and tuberculosis chest X-ray, and I got the new total accuracy from accuracy of chest X-ray, pneumonia X-ray, and tuberculosis accuracy. I name as new total accuracy is the system accuracy. The 73 is the whole system accuracy. I did the quantitative and qualitative evaluation. I did the evaluation with medical expert and technical experts. I did the self-judge evaluation also. Overall evaluation feedback is good. Some evaluators gave me suggestions also, and limitations and further enhancement. Actually, the second one is I actually got some nurse's idea. When I going to do evaluation, I catch this idea. In Finally, it can be developed as a mobile application. The X-ray chest can detect other disease of cancer. Such a disease include lungs cancer or emphysema, like that. During the design phase, skills in design UML diagram were using. The new skill is I have never used Python before, so language can be learned online courses, PDF and other materials. I know about image processing, but don't know about much CNN. So I did some study to do this project. Then I have some knowledge, good knowledge about the CNN. The final conclusion, actually the primary objective of automated diagnosis of the disease pneumonia and pulmonary tuberculosis was to research, design, develop, test and evaluate software applications that could differentiate between selected two diseases. The project has been designed to enable the doctors, nurses and health staff to gain the benefit in short time period. This work was completed positively. This research project can be considered as a success, as all the other objectives set at the beginning of the project, and its objective were successfully. This is my presentation. Thank you.